Okay, so this lesson's revision is going to be on arithmetic and geometric sequences. So we'll start with a quick recap and then we'll do 3 exam questions where I show you how to pick out key information. So arithmetic, that's when you add each term by a constant difference, which we call D, to get the next. So like 3 add 2 is 5, add 2 is 7, add 2 is 9, etc., etc. Whereas geometric, you multiply each term by constant ratio, which we call R, to get the next. So 2 times 3 is 6, times 3 is 18, times 3 is 54, etc. For arithmetic is the first term, the common difference. And so our sequence is A plus D, A plus 2D, A plus 3D, etc. For geometric, A is still the first term, but R is the common ratio. So we get the sequence A, AR, AR squared, AR cubed. Now it's important to realize that AR cubed means A times R cubed. It doesn't mean AR, then cube it. Yeah, remember BIDMAS, powers first. So to find the common difference for an arithmetic sequence, we find the common difference between 2 consecutive terms. So you do second takeaway first, third takeaway second, and make them equal, and solve for D. Whereas for the common ratio, for a geometric one, we find the common ratio between 2 consecutive terms. So we do U2 divided by U1 and U3 divided by U2 and make them equal. And then we'd solve that for R. If the question asks us to do that, because that's sometimes a common question. The formula for the nth term, so this is to get a specific term in the sequence. For arithmetic, it's un equals a plus n minus 1d, and you need to know that. So that's for working out the 10th term, the 20th term, the 15th term, etc. So one specific term. Or equally, you might be told the 7th term equals 10, so you would use that formula and make it equal 10. For geometric, it's un equals ar n minus 1. Now the sum formulas, you get given these. So the sum of the first n terms, that means we add together the first term, the second term, the third term, all the way up to the nth term. For arithmetic, it's n over 2, first add last, a plus l, or you can sub in what l is just un, so it's n over 2 times 2a plus n minus 1d, and notice the brackets. For geometric, it's a lots of 1 minus rn to the power n divided by 1 minus r, or you can times top and bottom by minus 1 and have it as rn to take away 1 over r minus 1. I always use the first one, but I know that some people prefer using the second one if r is bigger than 1, because they don't like dividing by negative. Also for geometric, for infinite series, sometimes they converge to an answer. So if the terms keep getting smaller, then it'll converge towards a number. And the formula for that, the sum to infinity is a over 1 minus r, and that only works if the modulus of r is less than 1, which means r is between minus 1 and 1. So our first exam question, show that the sum from r equals 1 to 16 of 3 plus 5r plus 2r to power r equals 131,798. Now notice it's 4 marks, so that means you can't just type that in your calculator and write down equals that number. That won't get you any marks. One way you could do it, you could write out all 16 terms and add them together, but you don't want to waste time in the exam because it's only 4 marks. So the best technique is to double check how many terms there are. So since there's 16, that means that they don't want you to write down all the terms. They want you to spot a pattern. So since it's a sum question, I'm going to write down my 2 formulas I'm given, because I might have to use one of them. Then I'm going to write out the first 3 terms. So I'm going to sub in r as 1, so I get 3 plus 5 plus 2. And notice how I'm leaving those numbers separate, but I'll add them up at the end and then get 10. So what I'm trying to do is I'm trying to see there's a pattern. When I sub in r as 2, I get 3 plus 10 plus 4, and that equals 17. And when I sub in r as 3, I get 3 plus 15 plus 8, and that equals 26. So if I look at the totals at the end, the 10, 17, and 26, I can't really see a pattern there. That's not arithmetic, it's not geometric, so I can't really do anything with those end numbers. But if I look at the numbers in the middle, well, that first column is just 3 each time. That second column is going up in fives, so that's arithmetic, 5, 10, 15, 20, etc. And the last column is times them by 2 each time, so that's just geometric, 2, 4, 8, 16, etc. So I can work out the sums of those 3 columns separately and add them together. So our first column, nice and easy, is a constant sequence, just 3. So to get the sum, well, there's going to be 16 lots of 3s, which is 48. The second column is arithmetic. The first term is 5, and the difference is 5. So sub it into the formula, and we get that total is 680. And then the last column is geometric. A is 2, R is 2. So sub that into the formula, and get 131 or 70. And then add those 3 numbers together to get the overall sum. And we get that answer 131,798. Yeah, so always think, what's the examiner going to be testing? Well, they have to test, do you know your formulas for the sequences, or can you apply the formulas for the sequences? Second one, so maybe just pause this one, see if you can try this yourself. So I'm going to talk you through my process of how my brain would work doing this. So the 7th term of an arithmetic progression is 6. Well, the first key thing to me is arithmetic progression. Progression just means sequence. So as soon as I see arithmetic in my brain, I get the formulas ready. So I get UN ready and SN ready. I also noticed they mentioned the 7th term, which I can think of as U7, and they've told me that is 6. So I can make an equation, U7 equals 6. But if I look at on my box to the right, I have a formula for U7. It's A plus 7 minus 1D, which I can simplify to A plus 6D. So I get an equation, A plus 6D equals 6. I can't do anything else, so I'll carry on reading the question now. The sum of the first 10 terms of the progression is 30. And again, so my brain picks out the sum of the first 10 terms, which I can write as S10. And it's told me that that's 30, so I can write a formula, S10 equals 30. I've got a formula for S10, so I'm going to sub 10 into that formula. So 10 over 2, lots of 2a plus 10 minus 1d equals 30. So I'm going to simplify that to get 5 on the outside and 9d on the inside. Now, instead of expanding, divide if you can. So I can divide both sides by 5 to get 2a plus 9d equals 6. So I've got another equation there. Now, before I carry on reading, I've got 2 equations. I've got A and D, so let's just write those 2 equations out. Now, I can solve them simultaneously to get A and D. So I would just cheat and use my calculator. So A is minus 6 and D is 2. Okay, now I need to keep reading because the question might not want that, it might want something else. So the question says, find the 5th term of the progression. So again, my brain tells me 5th term means U5. So to get U5, the formula is A plus N minus 1D, and I know what A is, I know what N is, I know what D is. Work it all out, and we get 2. So 5 marks. Easy question, easy 5 marks. Okay, and last one. Again, try and pause it, see if you can do the same thing I did, where you break it down into formulas. So the 2nd term of a geometric progression is 24. So again, my brain tells me geometric progression, so I get the formulas ready in my head. The 2nd term, which is U2, is 24. So I can write a formula for that. U2 equals 24. So AR 2 minus 1 equals 24, which I can simplify to AR equals 24. Can't do anything else with that, so I carry on reading. The sum to infinity of this progression is 150. So sum to infinity, that's S infinity, and that equals 150. So I can write an equation, S infinity equals 150. I've got a formula for S infinity, A over 1 minus R equals 150. So I've got 2 equations now. And the question says, write down 2 equations in A and R, where A is the first term, R is the common ratio. So I've done that. So I'm going to solve the equations now. So A over 1 minus R equals 150. So I can times both sides by 1 minus R to get A equals 150 lots of 1 minus R. And just to help you, I would expand that. So A equals 150, take away 150R. If you're confident with algebra, you don't have to expand it, but otherwise it might be useful to expand it. Okay, now I've got A equals, I can sub it into the other equation. So AR equals 24. Sub in what A is. Now expand that bracket. Now it's just a quadratic. So take everything to one side. Now you could just type that in the calculator now, but if you're doing this by hand, you have to simplify it first. So I've simplified all the coefficients for you. Sub it in your calculator, and you get R equals 1/5 or 4/5. Now in the question, I haven't underlined this, it is possible values. So that's good, I've got more than one answer. Now they're both less than 1, which is good. So that means that both are possible values. I can't reject any. So all that's left to do is work out A. So sub each in. So when R is 1/5, A equals 150. Take away 150 off to 1/5, which is 120. I'm just using the formula at the top of that column for A equals 150, take away 150R. Do the same for R equals 4/5, and we get 30. So my possible values, A could be 30 and R is 4/5, or A could be 120 and R is 1/5. Yeah, when you break down questions like that, it becomes nice and easy. Like I can ignore the rest of the question as soon as I pick out the key bits. So can you have a go at doing the exam questions I set you, and let me know if there's any issues.